on record, otherwise I'm forgetting it. So now I'm recording. Here you go. So the reason why we review P6 the first is because in chapter 1 we are solving quadratic equations that may be familiar to you with the quadratic formula. And when we do that, we have to simplify as much as possible. So it's always a good idea to know what the square root of 16 is. What is the square root of 16? 4. So the first part in P6, I want to talk about square roots. Now, before the square root of 16, I asked you, everybody said 4, because it's something we learned a long time ago. Now, a square root consists out of, this is called a radical symbol or square root symbol. Not all radicals are just square roots. I can't spell. Now, you have something, some radicals have a number here, like for example, the cube root, the fourth root. When you don't see a number there, it's understood to be what? It's understood to be a 2. A 2 square roots don't show that 2 there, but that number has a special name, it's called index. So the value on the outside is your index. The part on the inside is called a radicand. And sometimes this radicand has an exponent. So if you don't see a number there, it's automatically understood to be a 2. And the 2 is a square root. A square root is, I guess, our most common root. So that's why we don't put an index on a square root. So the whole thing is called a radical. The symbol is a radical symbol. The number here is the index. Inside is the radicand. And sometimes this radicand is raised to an exponent. So there's also something that's called the principal square root. The principal square root. The principal square root, for example, if you have the square root of a equals b, that means that b squared is equal to a. If b squared is some kind of number, if you take the square root, then you're basically finding that number multiplied by itself. Like the square root of 9 is equal to what? 3, because 3 squared is equal to 9. So you're finding that exact same number that multiplies to the radicand. Square roots and squaring something, I call them brother and sister. They are inverse functions of each other. And so for right now, we're just talking about perfect square roots because the square root of 25 is 5. They are perfect square roots because you don't come up with some kind of decimal here. The square root of 25 is 5. Please don't say 5 squared. 5 squared is 25. What about fraction action? Do you like fractions? How about the square root of 49 over 36? How do you simplify perfect square fractions. In this case, they're still perfect. Well, you take the square root of the top, you can rewrite it into the square root of 49 divided by the square root of 36. You don't even have to do that. But the square root of 49 is 7. And the square root of 36 is 6. So if you happen to have a fraction as your radicand, you just take the square root like you would individually of numerator and denominator. Everybody good so far? You want to do one more? Ha! Let's do one more. Square root of 50. Is 50 a perfect square? No. Now what? Don't go on the calculator and punch in the square root of 50 and you get 7.1 and whatever change. No, this is not about decimals. We don't work with decimals at all because decimals have rounding errors, and we want to find in algebra, especially if you go into engineering, you want to find exact answers. So what needs to happen here is you need to factor this 50 into a perfect square and whatever is left over. What is the largest perfect square that goes evenly into 50? 25. So this 50, square root of 50, you can rewrite it into the square root of 25 times the square root of 2. I really haven't changed the problem. I just split them apart and I put them in factors. Now I factor whatever, I can simplify whatever I can. The square root of 25 is what? 5, but the square root of 2 cannot be simplified, so we're just going to bring it down and rewrite 5 square root of 2. That is what is called an exact answer. If you were to multiply that and use a calculator, you would come up with 7 point something, probably 7.1, at least close to, because 49 is 7, so 50 is a little larger. So that is something you definitely have to remember in chapter 1. How about one more? My favorite number. How would you simplify the square root of 48? Square root of 48. What is the largest perfect square that is a factor of 48? Now, perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All the numbers that I listed there are perfect squares. Which of those numbers goes into 48? 16. So we're going to rewrite the square root of 48 into 16 times what? 3. So you can write it like that, or you can write the square root of 16 times the square root of 3. And now you need to simplify. Square root of 16 is 4. The 3 cannot be simplified, and it's just going to stay 4 radical 3, if you want to call it, or square root of 3, 4 times square root of 3. There is, you don't see it, but it's understood that this is kind of multiplication, 4 times square root of 3. If you don't see a sign in between, it's automatically understood it's multiplication. Everybody with me? Yes? Now, let's kick it up a notch. Yes. How about, and this can happen when we solve quadratic equation, and of course I will explain it again. How about the square root of -4? It's an imaginary number. Square root of -4. There is no way we can find two exact same numbers that multiply to -4. So Swiss mathematician Mr. Euler had the idea, okay, somehow I got to make this a perfect square. So he came up with I, imaginary number, I squared is equal to -1. That means I by itself is the square root of -1. Now, out of that square root of -4, I can now write 4 times -1, which is 4 times I squared, because -1 by Mr. Euler and his calculations said I squared is -1. I'm just substituting for I squared. I'm going to write for -1. I'm going to write I squared. Now, everything is a perfect square. Now I can simplify, and what do I get? 2I. Done, you are. Now, of course, it would be plus minus, but we're only looking at the principal square root, which is always the positive one. How about the square root of -36? 6i. Now, what time is it? The square root of a -3. How would you simplify that? A little tip, rule of thumb, whenever you see a negative inside the square root, an I has to come out, make it positive. So this becomes I square root of 3. Now, the square root of 3 cannot be factored, it cannot be simplified. Guess what? That is your answer. Let me see what else we have in P6 here. So I'm only going to cover stuff that we need for chapter 1. Let me make something up. How about we have something similar to an answer when we do quadratic formula and we get 6, I'm making this up, plus minus negative 64 all over 2. Let's say, and I will explain this one, this is the expression we have, and you have to simplify that. How would you do that? We have a 6 here, plus minus. First of all, you need to simplify the square root of -64. That is what? Square root of -64. You said I, but there's something else. What's the square root of 64? 8. So that would be 8i. Did you say that, Letitia? No. Okay. And that all divided by 2. Everybody see where the 8i comes from? Now we're not done yet. We have to reduce even further. Let's make a little heart out of it since Valentine's Day is coming up. Each number on top has to be divided, if we can, by the number in the denominator. Looks like a heart. Okay. 6 divided by 2 is 3 plus minus 4i. So if we can, you have to simplify as much as possible. Any questions? That's really all I want to do from P6. So like I said, don't worry about the P6 homework, but we got a minute. I just want to do one problem. Please take a look at the videos, and in next Monday, we're going to solve linear equations. Linear equations are in 1.1, so let's just practice this one here, and then we are done for today. 3 times x plus 2 equals 4 minus x. And I will go more into detail of linear equation. I just want to give you a taste, plus I also want to see if what you know, what you don't know about linear equations. So I'm going to give you a minute, because that's all we got time. Linear equation with one variable. Linear equations have an understood exponent of 1 on the variable. If you graph them, they would be a straight line. And let's see, how do you solve a linear equation? Again, I will talk more about this next Monday. I just want to give you a start. We have 3 and then we have parentheses. How do we clear the parentheses? That must be first. We're distributing the 3 over the x and the 2, so that would be 3x plus 6 equals 4 minus x. And then we have to do what I call moving and shaking. We want to isolate the x. We want to get all the x on one side and all the numbers on the other side. Which way you do that is up to you. We're all creatures of habits, so I always say letter to the left, numbers to the right, but you can do that either which way as long as you get the same answer. Does anybody want to tell me their next step? And I will go. Yes, Jessica? I'm going to add the x to both sides. Always have to do the opposite. 3x plus x is 4x. That means that 6 has to go to the other side in form of minusing it. So if we have opposites, they cancel each other out. 4x equals negative. 4 minus 6 is negative 2. What's the last step? Divide by 4. X equals negative 2 over 4, which can be reduced into negative 1/2. There you go. So I'm going to stop right here because